All right, let's pick up where we left off. Our next definition is reciprocals. If a number is multiplied by his reciprocal or inverse, the answer is 1. Let me explain what that means. Now they do it with the A's here. I'm going to do it with numbers so you can see it. If I take the number 2 and multiply it by his inverse. Now the inverse is like the flip or the invert, like the flip of it. If I take the number 2 and you're thinking, well, there's nothing to flip. Remember, any number can be written as itself over 1. So the inverse, the reciprocal, or the multiplicative inverse or reciprocal is 1/2. Now when you're multiplying those two numbers together, do you see how the 2's and the 1's would cancel? Do you see how if you multiplied straight across, you'd get the answer 1? That's what's happening there. But it can also happen in a fraction like 2/3. And that's one of the problems we have coming up. If I take 2/3, what would his inverse look like? What would the reciprocal look like? 3/2. You just flip it. And cancel, 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 and we get 1. Or 6/6 would still be 1. That's what that definition is trying to say. Now, when they ask us to find the reciprocal for the following, I'm going to start by putting the 7/1. You've got to have something to flip. So give it to yourself. If it's a whole number, you put it over 1 first. Now, that reciprocal is going to be 1/7. The reciprocal of 2/3 would be 3/2. And the reciprocal of 13 would be -4/3. It doesn't matter, well, on a negative fraction, the negative can be written out to the side this way, or on the top, or on the bottom. I always like mine on the top for some reason, but that's still going to be a negative number. That doesn't change. Dividing fractions. Now, we've shown you how to multiply in the last video. In this video, we'll spend the rest of the time talking about division of fractions. To divide fractions, we actually turn it into a multiplication problem. What we do is we write the first number down, and then we multiply by the reciprocal of the second that is being divided by, like this. If I have A over B divided by C over D, it's equal to A over B. Now notice, that stayed exactly the same, didn't it? But we turned the division into a multiplication. Do you see that? But we multiply by the reciprocal. So instead of C over D, we're multiplying by D over C. And then you multiply straight across. That's how we get AD over BC. But let's try it. On number 14, we make every division problem into a multiplication problem first. You're going to bring down the 2/9, and we're going to multiply by the reciprocal of the second number that's being divided. Instead of 5/6, we're going to multiply by 6/5. Now we can cross cancel and do the multiplication. I can't reduce within either term, but I do notice that 6 and 9 both have a 3 in common. 6 divided by 3 is 2. 9 divided by 3 is 3. Now we can multiply straight across. 2 times 2 is 4, and 3 times 5 is 15. That again. We have -5/6, and we know you write that one down exactly as it appears. Anytime I have a negative fraction, I have found that it is to my advantage to put the negative on the top like that. Now, multiply by the reciprocal of the second fraction, because we don't actually divide, we convert it, right? So now we're going to rewrite that as 4/3. Now look to see if you can reduce within each fraction. I don't see anything there, but we can reduce 4 and 6 by a factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now we're ready to multiply straight across. -5 times 2 is -10, and 3 times 3 is 9. Let's try it again. And again, pause the video if you need to slow it down. 1/6 divided by -2. I'm going to start off by rewriting rewriting this as a multiplication problem. That is 1/6 times. Now I'm going to need the reciprocal of this number, so I'm going to start by putting it over 1. The reciprocal then is going to be -1/2. Doesn't matter if the negative stayed on the 2 or out to the side. I just prefer to always put a negative fractions sign on the top. Now look to see if you can reduce within each term or diagonally. And on this one I can't. So I'm going to go ahead and multiply straight across. It is -1/12. Next one. I want to rewrite it, but I don't like the 3 just being there all by himself, right? So I'm going to put it over 1 first. And instead of division, we're going to multiply by the reciprocal of the second one. Remember, the first number comes down exactly as it appears, and you multiply by the reciprocal, so that becomes 5/6. Now see if you can reduce within each term. 3/1 don't reduce, 5/6 doesn't reduce, 5/1 doesn't reduce, but 3 and 6 both have a factor of 3 I can reduce. 3 divided by 3 is 1. 6 divided by 3 is 2. Now multiply straight across. 1 times 5 is 5. 1 times 2 is 2. All right. Now, we are going to talk about this in a later section, but I do want to talk about something that's interesting here in these 4 answers. Did you notice that these fractions have the smaller number on the top? These are called proper fractions because it's ideal to have the smaller number on the top. These 2 fractions are called improper fractions because the larger number is on the top. And that will be discussed a little bit further in the next section, okay? Now, on number 17, the SPC Math Department has a collection of 80 non-graphing calculators. If 16 of those calculators are defective, what fraction of calculators owned by the department are defective? So we need a portion that we're describing over the whole. What is the total? Let me call it total. What is the total number of calculators that we had? We have 80 total, and we know that a portion of them, in this case, we're wanting to talk about the fact that 16 of them are defective. So I'm going to put the 16 up here. Now we can reduce that. I'm going to write down the prime factorization of the number. 16 is 4 2's. 80 is 4 2's and a 5. Cancel, 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 cancel. So in reducing it, 1/5. 1/5 of the calculators in the math department are defective. That was kind of neat. Let's look at the next one. Granzy is making batches of Granzy? Okay. I guess it's a grandmother, is making batches of chocolate chip cookies to give her grandchildren. She has 4 cups of chocolate chips. Okay. And each batch of cookies takes 2/3 of a cup of chocolate chips. How many batches can she make? So I've got these 4 cups and I want to break them up into 2/3 cups so that I can figure out how many batches of cookies I can make. So I'm going to divide the 4 cups by these 2/3 cups that I need. So let's see. I don't actually need the 4 as a 4. I'm going to put it over 1. And to divide, I actually have to convert it to a multiplication problem. So it's going to be 4 times 3/2. Now, can you reduce within each fraction? No. Can you reduce diagonally? Well, the 4 and the 2 both have a factor of 2 in common. 4 divided by 2 is 2. 2 divided by 2 is 1. And so we can multiply straight across, and I'm going to get 6. But that actually is just the number 6. You can make 6 batches of cookies because you've got those 4 cups. And they can make 6 2/3 cups. That's what that is telling us. I'll see you in the next section.